Right, so welcome to today's lecture. So today we are discussing quadratic functions, and to be specific, we'll be looking at how you can sketch the curve of a quadratic function. So sketching curves of quadratic functions requires you to know certain things, certain steps. Yeah, so we are going to discuss those steps today. And you also have to make sure that at least you know how to complete the square of any given equation, any given quadratic equation. And then apart from that, if you don't know how to complete the square of quadratic equations, I'll show you another simple method you can use to sketch quadratic equations even without completing the square. All right, so let's quickly begin. All right, so we'll first start by looking at what a minimum and a maximum value is. So sometimes before they ask you to sketch the graph of any quadratic equation, they'll first ask you to determine whether the quadratic equation has a maximum or has a minimum. Or sometimes they'll ask you to find the minimum value. So this is what they mean. So for instance, okay, let me just connect my tab. All right, so, okay, so if they ask you to find the minimum or the maximum value, we know to say a quadratic equation, the curve of a quadratic equation can either come out like this or like that. So when it is like this, the minimum point, this one, we say the quadratic equation has a minimum point if you have something like this one. Then if you have a curve which comes out like this, we say the quadratic equation has a maximum value. At this point where the quadratic equation is turning, we call this point as a turning point. Sometimes it's called a stationary point. So this one is called a turning point, and at this point, I mean, this same point is the one that we call the minimum value. Okay. Someone is saying, I can't hear you. It may just be maybe the network where she is. Huh? Is everyone able to get me?
Yes.
All right.
Yes. I think it's just the network.
All right. Okay. So this point at which, I mean, this point where the curve is turning is called the turning point. And then this same point sometimes is known as the stationary point. And if you have a curve which looks like this one, if you have a curve which looks like this one here, the first one, you say this curve has a minimum value. So this one has a minimum value, and then this one has a maximum value. And then at this point, and then, okay, before I even talk about that, we have a line which divides this curve into two equal parts. So this line is called the line of symmetry, and it's found by x is equal to negative b over 2a. So this is the this is one of the most important equations that you can use to sketch or to find the turning point of a quadratic equation without completing the square. And then at this point, the value of x will still be x is equal to negative b over 2a. And then the other thing you need to know is that if they ask you to find the minimum value or the maximum value, after completing the square of any quadratic equation, let me just put up some notes. Yeah, so after completing the square of a quadratic equation, this is the answer that you get. So when you equate this part to 0, when you equate this part here in the brackets to 0, so when you equate this to 0, you're going to have x plus b over 2a is equal to 0. And then to find the value of x, you take this b over 2a to the other side of the equal sign. So you say x is equal to negative b over 2a. So this is the value of x at the turning point. So now to find the minimum or the maximum, you just get this part here. and replace the values there. So if you can't manage to complete the square of a given quadratic equation, you just get this part. You just say y is equal to b squared. Let me write them properly. Okay, so we say y is equal to negative b squared over 2a plus c. So this is what is used to find the minimum or the maximum value. So whatever you get here after completing the square, you call it the minimum or the maximum. Normally, we know to say after completing the square of any quadratic equation, the answer that you get is usually in the format y is equal to x plus b to the power 2. Then you have plus c this side. I've just given them letters. These are not the letters that you can use. I've just given them any letters in short. Yeah, just picked any 2 letters. So you can say after completing the square, you can have x plus b. I'm not saying this b is the one that you find in the quadratic equation. No, that's why I've said I've just used, let me use different letters apart from b and c. Because after giving an exercise, I can see drama. I see things in exercises. All right, so y is equal to, you have something like x plus, this one can be any number. Okay, let me just put numbers actually, instead of putting letters. So after completing the square of a quadratic equation, of a certain quadratic equation, you discover that you have maybe something like x plus 2 to the power 2 and then plus 5. So if you've been taught to find the maximum or the minimum value, you just say the minimum value is y is equal to 5. You just get this number that is there. That's what I meant by getting this part. You just get the number that is outside there. And then this minimum value occurs when the value of x plus 2 is equal to 0. So I've just gotten what is inside there and I've equated it to 0. Hence we get x is equal to negative 2. So whatever is there, you just equate it to 0 and then you get this as your minimum or your maximum value. Now, how do you know it's how do you know to say what is what is this side is a maximum or a minimum? How can you tell that? So you look at your quadratic equation. When you look at this quadratic equation, it's in the format ax squared plus bx plus c. So now if the value of a is greater than 0, then it means that the given quadratic equation has a minimum value. So you expect it to come out like this. And then if the value of a is less than 0, it means that the given quadratic equation has a maximum value, meaning you expect it to come out like that after sketching. So you have to put these in mind. So this is the simplest way you can sketch a quadratic equation, just by saying, okay, we'll look at an example and I'll use 2 methods to sketch the same quadratic equation. We'll look at one example, but I'll use 2 methods, the simplest one and the completing the square method. It's one formula, but the simplest one, you don't have to complete the square, you just have to go direct. Yeah. So I'll solve one question, but the most important part you need to know is this part here. When a is greater than 0, then you have a minimum value. So your curve comes out like that. Then when a is less than 0, meaning if you have a negative in front of a this side, you expect your curve to come out like this. It should have a maximum. So meaning whatever you are going to find this side after completing the square, you discover that you are going to call it as your maximum if the value of a is negative. And then if the value of a is positive, meaning it's greater than 1, rather it's greater than 0, whatever that is this side here, this 5 here, you call it as a minimum when the value of a is greater than 0. So in this case, we can call this 5 as a minimum value because we know that a this side is positive. But if we had, for instance, negative 2 this side, as long as there is a negative in front here, we can tell to say, okay, here the value of here we can tell to say here the value, this 5 here, will be a maximum because we have a negative in front of the brackets. Yeah, so this same A which is here is actually the same one which is always there. All right, so let's quickly look at some example from your handout. All right, so this is just what I'm just talking about. So we know that the value of x at the turning point is given by this. And then this one is the one that we're calling the line of symmetry. Remember, I talked about a line that divides this quadratic equation into two equal parts. This is the line. You just say x is equal to negative b over 2a. That is the line. All right, so this is what it means. Okay, let us quickly move on to the next part. All right, so the minimum or the maximum value. So, okay, I'll explain this in the next equation, in the example. All right, so we have f of x is equal to that. And then the question is find the maximum or the minimum value. The maximum and the minimum, or the minimum point, and the value of f of x. Hence sketch the graph of f of x. So what you just need, I'll start first by using the completing the square method, completing of the square method. So the way you complete the square, we learned, and I believe most of us know how to do it. Yeah, so in case you don't know, find time to revise. Okay, so we have f of x is equal to that. We have f of x is equal to negative 2x squared plus 11x minus 15. So now how do we complete the square of this? So the first thing that you need to do here is you factor out the negative 2. You factorize the negative 2. So we have f of x is equal to, when you factorize negative 2 there, we're going to have open brackets there. We remain with x squared, and then the next one will be negative 11 over 2 x. Then we have minus 15 outside. So from there, we can now find half of negative 11 over 2. So I'll put my negative 2 outside. Then I'll write my x squared there. Then I'll say plus half of negative 11 over 2 will be negative 11 over 4. This is the half of that. Then we subtract this same half. We square it, and then we subtract this same half. Then we write this part, which is a minus 11 over 2x. Like that. Then we have minus 15 outside. Okay, have to square this part as well. So from there, we say minus 2 and then open brackets. So we can say x, then we have negative 11 over 4. We put them in brackets and square. Then we say minus 11 times 11, the answer is 121 over 4 times 4, the answer is 16. And then we say minus, oh, not so. We forget about this minus 11 over 2. So we close the brackets there. Then we say minus 15 outside this side. So we can now multiply everything by negative 2. So I'm going to have negative 2 times that. We have negative 2, open brackets, negative 11 over 4 squared. Negative 2 times this, we're going to have positive 121 over 8 minus 15. So when we simplify this, we'll have something like this. Negative 2 outside, open brackets, we have x minus 11 over 4, close brackets, squared. And then when you add 121 over 8, when you add it with 121 over 8, when you subtract 15 from 121 over 8, you discover that the answer that you get will simply just be a 1 over 8. So this will give you something like 1 over 8. You're going to have plus 1 over 8. So now, the question was asking us to first find what? Find the minimum or the maximum point and value. So how do you find the point and how do you find the value? There are two things here. So the maximum value or the minimum value. So in this case, we first have to determine whether it's maximum or minimum. How do we know? we check the coefficient of x squared. So the coefficient of x squared is negative, meaning we know that our a is less than 0. So the coefficient of x squared is called a. So -2 is less than 0. So this one tells us to say the given quadratic equation has a maximum value. So this one has a maximum value. Now that it has a maximum value, the other thing that we need to check, so we've answered one part, which is the value part. Now, how do you find the, oh, sorry, we've not yet answered the value part. This is just determining whether it has a maximum or minimum. So now to find the maximum value, you just get this 1/8 and equate it to y. So the maximum value, we say the maximum value is equal to, or implies that y is equal to 1/8. This is the maximum value. And then the other thing we need to find is the maximum point. How do you find the maximum point, which is just the turning point? So we equate what is in the brackets to 0 to find the value of x at the maximum point. So we equate x minus 1/8 to 0. So we're going to have x is equal to, when this 1/8, -1/8 crosses the equal sign, we'll have 1/8 there as the value of x. And then the value of y is simply just that, oh, sorry, we have 11. This one is 11/4, not 1/8. So I got this part here, which is x minus 11/4. This is the part that you're supposed to equate to 0. So we have 11/4, we equate it to 0. So, and when this negative 11/4 crosses the equal sign, the answer that you get to be positive 11/4 as the value of x. So meaning to find the maximum point, so the maximum point now, the maximum point is equal to 1/8, 11/4. So in this case, this is our turning point. So we have managed to find the turning point. We've managed to find the maximum point and the maximum value. The maximum value is y is equal to 1/8. And then the maximum point is 1/8, 11/4. So we are done with that part. So now let's move on to the part of sketching. So before we sketch, we need to find the points at which the quadratic equation meets the x-axis. So how do we find those points? Because we know to say, just from these 2 points, we can approximate how the curve will come out. So we know to say the maximum point is 1/8, 11/4. 1/8, which is somewhere, I'll approximate it to be somewhere here, 1/8, 11/4. Yes, Linda?
Yes, sir. Before you proceed to sketching.
Okay.
Yes, kindly repeat yourself on the maximum value.
The maximum value just is what is outside this side. What is outside the brackets after completing the square? So every time you complete the square, you always find yourself to an equation which looks like this one. A, open brackets, then you have x minus or plus, I'll use m squared, then plus n. So whatever that you find here is the one that we call the maximum or the minimum value. So this one is the value. It's just one number, it's a value. But to find the minimum or the maximum point, a point should be a coordinate, meaning it should have the x and the y axis. The x and the y coordinate. So the maximum value, I just got what was this side, which is just 1/8 in this case. When you check here, we only have 1/8. So that is what oh, sorry. I think I see why you asked that question. This is supposed to be 11/4, 1/8, not 1/8, 11/4. Because the x value is 11/4, so it's supposed to be there, 11/4, then 1/8. So even on the diagram here, you have to change Right, so we have 11 over 4 here and 1 over 8 in the y. So the maximum value is just the y coordinate at the turning point, the y coordinate at the turning point. So if we are to sketch this curve, knowing that it has a maximum value and the turning point is there, so it will come out like this. This is how it will come out. So this is the turning point. So at this turning point, the value of y at the turning point is the one that we call the maximum value. And then the turning point is the one that we call the maximum point. If it was minimum, if it was like this, we would have called it the minimum point and the minimum value. That's how it is. If the value of a was greater than 0. Okay. So the other important feature here that we need to know is the y-intercept. So the y-intercept is just this number here. This is the y-intercept. From just this equation, you get the value of c, the constant. That's the y-intercept. You can see that it's even making sense. It's in the negatives, negative 15. And then the other two important features you need to put on the sketch are the roots of the equation. So how do you find the roots of the equation? It's just by solving the quadratic equation. So the roots of the equations, remember what I said, the roots of the quadratic equation is simply just, they are simply just numbers at which the quadratic equation or the curve of the quadratic equation meets the x-axis. So we know to say at these 2 points, the quadratic equation is equal to 0. And the values of the y values at these 2 points are equal to 0. So how do we find that? So this one is straightforward. So it's straightforward. You just equate what you have done here to 0. So you just put a 0 this side. Let me just erase on top. So you just equate what you have found after completing the square, you equate it to 0, that's all. Then you find your x values. In short, you just solve the quadratic equation. When you solve the quadratic equation, the answers that you get are the values of x at which the curve cuts the x-axis. So when you equate 0 this side, you have 0 is equal to negative 2, open brackets, we have x minus 11 over 4, close brackets, and then we have squared there. Then we have plus 1 over 8. So I'll first start by taking this 1 over 8 to the other side of the equal sign, so that I have 1 over 8 is equal to negative 2, open brackets, x minus 11 over 4, close bracket, squared. Then from there, I'll divide everything by negative 2 this side, divide by negative 2 this side. When I divide everything by negative 2 this side, I'm going to, this one is supposed to be negative 1 over 8 because it's positive here. So when it crosses the equal sign will be a negative. So when I divide by negative 2 there, I'm going to get 1 over 16 this side. And then this side, I'm going to get x minus 11 over 8 squared. So now to get rid of this squared here, I'm going to square both sides. So when I square both sides, this side I'm going to have plus or minus. So this square and that square, this square root and the square there will cancel. So what I'll just remain with is this side, the square root of 1 is 1, the square root of 16 is 4. And then on this other side, I'm just going to remain with x minus 11 over 8. So this side there's a plus or minus, which I also have to add to that. So now I'll just have to take, oh, sorry, I don't know why I'm getting 8. This one is supposed to be 4. It's supposed to be 11 over 4. So now this will just cross the equal sign as well. So when it crosses the equal sign, I'm going to have 11 over 4 plus or minus 1 over 4. And then we say this is equal to, this side will just remain with x. So the first value of x would be 11 plus 1 over 4. So we're going to have the first one will be 11 plus 1 over 4 is equal to x. Then the other value of x will be x is equal to 11 minus 1 over 4, which is 11 minus 1 over 4. So the first one, 11 plus 1 over 4, this one will give us x is equal to 3. And then the other one will give us x is equal to 5 over 4. Oh, sorry. This will be 10 over 4, which is 5 over 2. 5 over 2. So now to write these numbers, you discover that the smaller number is the one that we're going to put there. Then the bigger number will be put there. So this is how you do the sketching using completing the square method. So after completing the square method, you now have to determine whether it has a maximum value or a minimum value. Then from there, you write your minimum value, and then you also write your minimum or your maximum point in short. Then from there, you find the x-intercepts. The x-intercepts are found by solving the quadratic equation, this same quadratic equation that we've been given. You can solve it. The reason why I just had to put a 0 this side, because I know to say when I'm completing the square, when I'm using the completing the square method, so when solving this quadratic equation, you always just you always just put a 0 this side and then complete the square on the other side, and then you do the procedure. And then from there, if you want, you can use factorization method to solve this one. You still find the same answers if you're able to use factorization method. And then if you want, you can also use the other method. Which one is that? Okay, there are a lot of methods you can use to solve these equations, but at your level, they only talk about the formula method, factorization, and completing the square. So you can also use the formula method to solve this quadratic equation. The answers will still be the same. And then those answers are the ones that you have to put there and there. They are the x-intercepts. Now to find the y-intercept, you just get the constant there, which is negative 15. In this case, that is how you find the constant. Yeah, so that's it. So let me now show you the simplest way to go about or to solve this quadratic equation. I mean, rather to sketch this a curve of a quadratic equation. So this one was using the completing the square. Now let us go direct to the one that is just straightforward. Okay. So the one that is just straightforward, we find the turning point, which is the maximum value, which is the maximum point. By the way, first we have to look at the quadratic equation. If what is in front this side is less than 0, then we know to say it has a maximum value. Okay, so you look at what is in front there. So when you say that, when you see that the coefficient of x squared has a is greater than 0, then it has a minimum. And if the coefficient of x squared is less than 0, like in this case, since a is less than 0, we conclude that it has a maximum value. So just after knowing that it has a maximum value, you can now find the value of x at the turning point. So how do you find the value of x at the turning point? The value of x at the turning point is given by negative b over 2a. So we know that a quadratic equation is always in the form ax squared plus bx plus c. So in this case, to find the value of x at the turning point, you say x is equal to negative b. So this time, in this case, we're going to have negative 11 over 2, and then the value of a there that I have is negative 2. The value of a is simply just the coefficient of x squared. So here, the value of x at the turning point is therefore going to be 11 over negative 11 over negative 4, which can also be written as 11 over 4. So we found the value of x at the turning point. How do you find the value of y at the turning point? So the value of y at the turning point is found by replacing this 11 over 4 in the whole equation there. So while there's x, you just put 11 over 4. So we have 11, let me start with writing 2. Let me start by writing 2. So we have negative 2 open brackets. And then we have, while there's x, we're going to put 11 over 4. Then we close the brackets. Then we say squared. And then we say plus, oh, this one, okay, it's a positive, yes. So we have plus 11, then open brackets, we have 11 over 4. We have 11 over 4. Then we say minus 15. So what you do to find the maximum value or the value of y at the turning point, you just replace the value of x at the turning point, you replace it in the main equation there. So we say y is equal to, so this one, when you simplify it, this will be 4 times 4, that will be 16, and then 16 times negative 2, that will be negative. So we're going to have negative 121 over 8. Then here we'll have plus 121 over plus 121 over 4, and then you say minus 15. So when you do your calculations there, you discover that your answer that you get will simply just be 1 over 8. So after simplifying this, the answer that you get will be 1 over 8. All right, so yeah, so let us now write this. So now the maximum value that we have is y is equal to 1 over 8, and then the maximum point can now be written. So the point, we can now write the point. So the maximum point will just be equal to, the value of x is 11 over 4, comma, the maximum value there, which is 1 over 8. So this is the point. So now, immediately after finding the point and the value, we can now find the y-intercept. So the y-intercept is simply just negative 15. So I can even start sketching up just after finding the maximum point. So I can even start sketching. Let me put it properly. So I'll write it here. So I'll start sketching. Let me put my point. I'll put 11 there over 8. And then, 11 over 4. Then we have 1 over 8. This is the point there. So from there, we can now, so that is the point. So from there, we can do the sketching. Yeah, so at this point, this is the y-intercept. So the y-intercept is simply just negative 15. So you're going to put negative 15 there. And then after putting negative 15, there, we can now find the x-intercepts. So the x-intercepts are simply just the points at which the curve is cutting the x-axis. Remember what I told you, you find these points by solving the quadratic equation. So this one, to solve it quickly, I'm going to use the formula method. So I'll say x is equal to negative b plus or minus the square root of b squared minus 4ac, everything divided by 2a. So the value of x at that point will therefore be equal to, x is equal to negative, our b there is 11. So say negative 11 plus or minus the square root of b squared will be 11 squared minus 4. My a there is negative 2. Then my c is negative 15. Then everything divided by 2 times, everything divided by 2 times a, which is negative 2 there. So the value of x will therefore be equal to negative 11 plus or minus, and then we say the square root of this one will be 121, then this one will give us 120 and negative 120. So 121 minus 120, this will give us 1. Then everything divided by negative 2 times 2 there will give us negative 4. So this one, when you simplify it, you're going to have x is equal to negative 11, the square root of 1 will be plus or minus 1, then everything divided by negative 4. So this one will still give us the same answers that we found. So we are going to have, the first one will be x is equal to 5 over 2, and the other x value will simply just be 3 when you simplify that. So you put your numbers there, you put your 3 there and your 5 over 2 there, and you are done sketching. So this is the simplest way you can sketch. Do you have any questions on this one? Do you have any questions before we can proceed? So I'm going
excuse me, sir.
Okay.
On the sketching, the graph, the way you've written it, after finding the 2x points, which is 5 over 2 and 3.
Okay.
Why is it that the 5 is written the other side, instead of if we're to follow the normal number line where you have 0, then the numbers go 1, 2, 3 up to infinity.
Okay.
Well, I'm just asking, like, why has it become 5/2, then the other 3 has gone the other side? I'm lost there.
5/2 is 5/2 when you use a calculator, or even just say 5 into, 2 into 5, the answer is 2. And then you remain with 1/2. 1/2 is simply just 0.5. So 5/2 is the same as 2.5. So 2.5 is smaller than 3. So 2.5 comes first than 3 there. Is it
All
okay?
right.
Yes.
Thank you. Yes, thank you.
All right, Alexander, you have a question?
I want to take you back to how you found y is equal to -121/8.
Okay.
Just the above equation there.
Okay. Okay, wait, so the link is about to end. So once it just stops, you can rejoin using the same link. Okay, you can continue. You can ask the question.
Yes, my question is, how did you find 121/8? Just there, the calculation on top there.
Oh, this one here.
Yes.
This one, 11 squared would be 121. 4 squared would be 16. And then